Welcome back to the session. Okay, I will share my screen. Okay, here is our Tekla model. Okay, we did just now. Now the step number 6. Okay, step number 6 is to assign the load. Okay, step number 6 is to assign load. Okay, on the slab for beam first, beam, and then on the slab. So, slab on the beam. Okay, here. Sorry, slab on the beam pula. Load on the beam is only GK, which is come from the brick wall. Okay, and the load on the slab is divided to GK and QK, and we assign as the area load. Okay, for the beam we assign as the UDL. Okay, uniform distributed load. Okay, so for the first one, we have to refer to this architect plan. Okay, to locate the position of the brick wall. Okay, so let's say we have brick wall here at the blue color. Okay, blue color is the brick wall. Okay, let's do for the ground level first. So you can go to here. Here you can go to the dead load. You can select dead load here. Okay, you can select dead load. Make sure. Okay, nampak tak kat bawah ni? Okay, select dead load. And then here, go to the load. Okay, model, edit and load. Go to the load. And then full UDL. And then here is under the dead load, you can enter the value. Okay, so for my case, since I mentioned before that the floor to floor height, our floor to floor height is okay here to here. Let's say this is our roof, this is our first, and then this is our ground. So the floor to floor height is equal to 3000 mm or 3 meters. So the load of brick wall here is the clear height times the load for brick wall. Okay, so the load for brick wall including the plaster and painting, I assume as 3.0 kilonewton per meter square. Okay, so let's say this is 1 meter, and then 1 meter, 1 meter. So we have 3 meters. So 3 meters is from here to here, but we have the beam here, the beam. Okay, so the depth of the beam, let's say 300. So or 500 or 400. So you must calculate for every situation, right? So let's say 500. So the clear height is equal to 3000 minus 500. So it's equal to 2.5 meters. So 2.5 times 3 is equal to 7.5 kilonewton per meter. So I can assign my load here. Type 7.5, and then I refer to the map. Okay, I refer to the layout. Where is the position of my brick wall? So it's in the perimeter. Keliling ni ada brick wall. This is keliling ni ada brick wall. Semua ni. So I select yang keliling tu. Here 7.5, 7.5. Okay. Yang bawah ni tak ada lah kan. Bawah ni tak ada sebab dia ada the porch. So di tepi. Balik. Here. Tepi. Senang je ni. Okay, and then lepas tu you pilih. Bawa ke tepi sini. Here and here. Lagi mana lagi? Ini, and then sini. Okay, buat je. Okay. Then here, sini, sini, sini. Okay, dah siap. Okay, this is for brick wall. Okay, yang atas pun sama juga. So you refer pada kedudukan dia. Cuma kat sini dia ada brick wall. Kat sini dia ada, let's say dia gunakan brick let's say dia gunakan brick, and then the brick wall here, and then here sini keliling ni pun dia adalah brick wall. Katalah dia gunakan brick wall. Kalau dia gunakan steel, lain cerita lah. Kalau kata brick wall tu 1.2 meters, so times 3 is equal to 3.6 kilonewton per meter. Okay, so kat second, okay, kita pergi load juga. Pergi load, kita open yang sini, select as a dead load, and then full UDL sama juga, calculation is 7.5. So saya lebih suka tengok kat yang 3D view. Okay, so boleh nampak jelas. Okay, so kat sini last year dia tak pakai brick wall, dia pakai apa, sliding door, tapi tak apalah, kita bubuh je. Okay, here dia pun sama, boleh bubuh je. Conservative design, we not calculate one by one. Okay, here. Okay, brick wall and brick wall. Dia ada pintu tapi tak apalah, kita bubuh je semua sekali. Okay, and then kat sini dia ada loading from, okay, tadi 1.2 meters tu, 3.6 is here. Di bawah nampak tak? Dia kecil sikit, dia rendah sikit sebab dia magnitude dia lebih rendah. So ni pun 3.6. Okay. Dan kat sini kita ada kat part yang ni, you nampak tak yang pitch roof ni? Sini ada bumbung kan? Nampak tak? Sini ada bumbung. Sini ada bumbung. Okay, so dia pakai bumbung ni gunakan, let's say so dia punya loading dia adalah ambil ni 1000, dia macam slab juga, and then bahagi dengan sini 2000, sini ada 4000. Sini 4000 bahagi 2 adalah 2000 here. 2000 2 meters, and here is of 1 meters. So dalam macam ni dia akan jatuh pada beam yang ni. Okay, dia pakai roof trusses tapi dia akan supported by this beam. So tributary area ialah 3 meter kali dengan 1.0 sebab untuk dead load. Okay, kat sini dia ada untuk case yang macam ni, untuk case yang ada pitch roof dia ada GK and QK. Kalau GK you kali 1.0 and then kalau QK you kali dengan 0.5 kilonewton per meter square. Okay, so untuk kat sini, kawasan yang sini adalah still in GK, we still working in GK. 3 kali 1 sama dengan 3. Okay, so full UDL now is 3. Masuk sini 3. Okay, tapi kalau kat sini, untuk part yang sini dia akan ada separuh lagi, dia akan jatuh pada beam yang ni. So jangan lupa, dia akan jatuh pada beam yang sini. So ini tadi berapa? Ni 2 meter kan? From here to here is 2 meters. 2 meters, 2 kali 1 sama dengan 2. Tambah dengan yang 7.5 tadi. So here kita just edit here. So to become 9.5 meters. 9.5 kilonewton per meter. Okay, sebab dia ada loading tambahan. And then we go to the live load. Live load, impose. Kat sini saja, untuk 2 ni saja. Because from untuk maintenance dan untuk air hujan. So loading adalah UDL. First tadi kali 3. This one untuk 3 meter ni. Kali dengan 1.5. Kali dengan 0.5. So jadi nilai ni adalah 1.5. Kat sini. Dekat sini nilainya 2 kali 0.5, so dia nilainya 1.0. Okay, so telah loading dia. Okay. So dekat roof atas sekali ya, this is quite complicated sebenarnya. Tapi you kena tengok bumbung dia jatuh arah mana. Tapi you boleh gunakan kaedah tadi ya, macam mana nak kira tadi, you kena macam seakan-akan dia untuk slab lah kan. Jadi here to here. So bahagi 2, you tambah dengan slab ni berapa. You kira lah jarak dia berapa. You find the distance and then you calculate. Okay, ini satu loading and then di sini adalah satu loading lagi. Okay. So for this case because we are running out of time, so I just do as, let's say, okay, maybe 5. But for your case you have to calculate, okay? Okay, because we are running out of time, it's nearly 5 now. Tepi dia 5, let's say, so kat tengah-tengah dia saya buat lah maybe double, maybe 10. Okay, for roof trusses. Okay. And then I buat the dead load, this dead load, and then the impulse load. Okay, tadi 5 yang kat tepi and kat tengah. Separuh dia half. But actually you have to calculate, okay, to get the exact value. Okay, based on the tributary area. And for actual, you have to determine the position of staircase, for the position of trusses, and then you assign as a point load. Okay, but for conservative approach, you may use this style. And then here for the impulse load, impulse load on slab. Okay, at the top we can go to the load and area. Area load here. Area load. You click area load, and then the area load is I want to be. You calculate your own. What is the area load for your water tank. Okay, water tank we treat as dead load. Okay, water tank. Okay, maybe water tank here we have 5. And then another one here is only 1.0 here. That is the dead load. And then for the impulse load, okay, all is 0.5 at the top. Okay, then go to the ground. For the ground case, the dead load on slab on the area, area is 1.0 for all. So you simply select all 1.0 kilonewton meter square. And then for the live load, for the impulse load, okay, you check the table. Okay, what is the value for bedroom, the kitchen, and so on. So I make it maybe 2.0, okay, but it's too big. 1.5 is okay. You have to check it from the Eurocode. What is the value of your QK? The porch, okay, for the porch area maybe is okay. For the porch, maybe the loading here is 4. Okay. Porch area. Okay. Then we go to the first floor. Okay, the impulse load. Okay, you must calculate this one actually. What's the value? So let's say 1.5 for bedroom. Okay, bedroom, and this is for the surau, maybe 2.5. Okay. And then here is another kawasan family area, 2.5. Sorry, here 5. Okay. Here is for corridor, maybe 4. Okay, and balcony house maybe 3. 3. Okay, this is impulse load. Okay, and the ground, maybe here is a living room. Maybe I want to enlarge to 2.5. Okay. Okay, so this is the loading. So you can see one by one, this is the impulse load. This is the okay, this is the dead load, and this one is the impulse load. Okay, and then you can save your work. Then you can validate your model. Okay, Alhamdulillah, it's validate. And then you have to go to the load again, and then you can go to the load combination, and then you just click generate. Then you just click OK, next, next, next. Okay, so this is our load combination. So click OK. Then make sure you save your work. And then for the design setting, you must go to the design. Okay, you go to the design and setting the design. Okay, this is the design setting for your beam reinforcement. Okay, minimum bar size, I want you to do 12 mm for the longitudinal bar. Okay, this is also 12. It's okay, you can check the video later about this setting. And then the link setting here, okay. I want it start by 6 mm and then end up by 10 mm as the link, okay. Then for the column, okay, we start the vertical bar by 12 mm. And okay, since this project is small, but 25 is okay. Okay, so this is the ratio of reinforcement. Okay, so this one. Okay, this is the setting. Okay. Then click OK. Then click OK, and then you go to the load. You can see here. Okay, this is the impulse load. Okay, you can see that there is no the impulse load is still not distributed or transferred to the beam. Okay, so you have to click decomposition. You have to click the decomposition. So validate first and then click decomposition. And wait. Okay, you can see here. Nampak tak ini the trapezoidal ni? This means that the load from the slab is already transferred to the beam. Okay, let me do it again. Let's undo. Tak boleh ya? Tak ni. Sebab dia dah run. Okay, tak apa. So kalau slide, you boleh tengok tadi, you boleh save as before you click the decomposition, you can kat sini tak ada slide load ke? Oh, sini tadi impulse load Sorry, saya tak buat. Okay, kat sini. Saya lupa. Okay, impulse load by area is 3. 1, 2, 3. Okay. So you see here that the load is still not transferred to okay. Now it's transferred. Yang ini pun ya. So you click decompositions. Okay, nampak tak ada kat sini. Dia dah transferred. Kalau tidak tadi tak ada. Okay, tak ada. I undo. And then I do click the decompositions. Okay, nampak dah ada yang sini. Dia muncul tiba-tiba. Means that the load from the slab is being transferred to the beam. Okay, and then everything is okay. You click validate model, and then you validate, and then go to design, and then click validate first. Validate the design, and then you can go to the design concrete gravity. And then here the software will do the analysis and proceed to design. Okay, we specified. Okay, valid combination. Go to load combination again. Okay, you generate. Make sure you have load combination. At least one. Okay, click OK. Then you save your work. Oh, because tadi saya undo tadi kan banyak kali. Okay, tak apa. Okay, this is impose load. Click again, decomposition. And then validate the loading, validate the model, validate the design, and then go to design. Okay, it's running for you now. Just wait. Maybe several elements will fail. Okay, so many fail element, especially the beam. We have beam, and we have fail for column, and also fail for the beam here. Okay, warning. Okay, warning. What if you have warning, and then you can go to the beam and then right click, check member, and then static, and then you can read why is warning. So it's a slender span. The span is slender. So H over H over B must be greater greater than 2.5. Now our H is berapa tu? H is 400 and our Bcom is 150. So berapa tu dia punya ni ratio dia? Tolong kira tak? 400 divided by 150, 2.6. Okay, so we enlarge this beam. Okay, we try to oh ni kecil beam ni. Tak apalah, so kita besarkan beam ni. Salah pilih size dia. Sorry. Tadi patutnya adalah ni kan 200 kali 500. Okay, so maybe kolom kita kena betulkan. Maybe kolom kita kecil sangat ni. Ada kolom yang kecil. Dia fail ya. Tapi kita boleh besarkanlah kolom kita ni. Dia fail kat atas pula. Bawah tak fail. Atas dia fail. Tak apalah. 1, 2. Kolom yang square tadi ya. 3 and 4. Maybe kita boleh besarkan dia. Jadikan dia 300 by 300. Okay. Okay, dah besar. Okay, tengok balik dia punya model and then click validate. And then design, validate, and then click design again. Your model is only 2-story model, so it's faster to settle. Masih ada fail lagi ya. And then you go to review, and then you can check the status. Apa yang fail lagi? Check member. Oh, fail kat tengah. Longitudinal bar, stop. Bar limit check. Maximum allowed steel area region 4,000. Okay. Maybe dia tak cukup reinforcement, so kena besarkan sikit lah beam tu mungkin. So maybe beam ni kita kena besarkan jadi 200 kali maybe 250 kali 500. Okay. Okay, maybe. So model validate and then design validate and then okay, now this beam is passed. Okay, so this is how you work. Okay, you will try go to element by element until it pass. Okay, until sampai semuanya hijau. Okay, maybe this column is fail. You can select design, interactive design. You can select one. Let's say here. Okay, so this is the design. So you can check why it's fail. It's okay. The design fail is because the AS provided is 2945. AS provided is 2945, but the AS maximum is 2400. So you have to enlarge the beam. We cancel. Let's say we enlarge here the beam here. We make it by maybe 250 times 350. Okay. So model we validate, and then design we validate, and then we design again. Okay, now this column is passed. So this is how you have to work. You have to check one by one. Okay, and then you change until it pass. Okay, any question? If no questions, I think we can end our session now. So thank you very much for your participation and for your cooperations.